Welcome to Lesson 3 of the course Guidelines for Dashboard Conceptualization. In this lesson, we will speak about the ways to represent quantitative data. When we think of a representation of quantitative data, we must think in terms of two aspects. One, how much are we talking about? The quantitative data itself. And then what we are talking about, the data from the categorical perspective. In the example in the graph that we see on the screen, there are sales in thousands of dollars in 4 different regions identified as North, East, South, and West regions. The amount of each region's sales is the quantitative data. It is what answers the question, how much? And the regions that we see below, identified as cardinal points, are the categorical data that tells us what we are talking about in terms of sales of the region. When we see quantitative data, we must understand that for them to be meaningful, they must always involve some kind of relationship. For example, these are some sales over time, sales in the different months of a year, and therefore we can compare in which months sales increased, in which month sales decreased, and which was the highest and which the lowest. We are always looking for some relationship between the data shown. But relationships are not one-dimensional. Relationships can be of many kinds. We may speak about a classifying relationship. For example, we have a graph of the employees at a company and we see how they are classified in different sections, divisions, departments of the organization, and thanks to the type of visualization chosen, we can easily see that the manufacturing department has the largest number of employees, almost 250. Next, we see that the following relationship is the sales department where there are about 170 employees, and so we can scroll down until we see that the marketing people have the lowest number of employees in that organization. We are relating the size in each of them according to the number of employees in each department, and we classify them from the largest in manufacturing to the smallest in marketing. Another way to analyze relationships is relating the parts with the whole. In this case, we have a similar graph to the one we have just seen, the percentage of the overall expenditures per region, and at the end, we see that there are 4 regions, and if we want to know the total expenditures of the company, we add the 4 regions, then we will get 100%. And we see that the northern region represents the highest percentage of expenditure, and the western the lowest level of costs. But we are comparing the relationship. The relationship that we are analyzing here is in what way each of these parts make up the whole, the 100% of the organization. Relationships can also be seen from the point of view of a deviation. For example, we see the difference in every department regarding its budget implementation, between what they had originally planned and what they actually spent. And in this case, we can see how in the sales department, for example, the implementation exceeds their budget. If the current and forecasted expenditures were equal, this data would be 0. It is not the case in sales, as I said, where the executed exceeds what was forecasted. But if we look at another departments like marketing or even human resources, where the execution is considerably lower in relation to what was forecasted, which is not the same case in other regions or departments. So if there's less expenditures, the deviation will be seen as positive, and negative if it goes upward. Negative in the sense that we have spent more money than was budgeted originally. And relationships can also be seen as a form of distribution. For example, in this graph, we see the number of orders we have by order size. Here we have orders received for less than $10 in a range of 10 to 20, 20 to 30, 30 to 40, or 40 to 50. And we can see how orders are distributed according to these categories. We see through this graph that the orders received in this organization are retail orders with mostly a cost below $10, while those which are 40 or higher represent the shortest distribution within the total. Finally, in a relationship, we can also analyze the correlation between indicators. In this Rather curious case, we see the relationship between an employee's height, in this case measured in inches, and his salary. 80 inches tall is equivalent to a little more than 2 meters. The height of 55 inches that we see below represent about 1.5 meters. And then we see how data are distributed throughout these quadrants that take shape, and we see how the people who are about 1.90 meters tall receive higher salaries in some cases. And also, the shortest person, that with the lowest height, has the lowest income, while the tallest almost has the highest income. In this case, apparently, it is better to be tall. Summing up, in the points addressed in this lesson, we see the representation of quantitative data and how this can manage a series of scales and relationships, and how we can analyze them from the perspective of a classification, from the perspective of parts making up a whole, from the perspective of deviations happening in results, distributions, and correlations. This concludes this lesson, and we get ready for lesson 4.